Morning. Hope everybody had a great weekend. Sorry for the confusion with this practice problem. I don't know if I guess I left something off, and then when I uploaded it or redid it on in a Google Doc, I don't know if it was accessible to everybody, but I believe it should be now. So if you need to go back in there and look at it or make any changes, you could do so. If you just watch the video today, look at the answer key, that'd be great, and I'll just assign a very similar additional extra practice problem for today's assignment. But here's what we were given, and not every problem that you'll be given will have to require the calculator in this way, where we would have to use list and spreadsheet, because here we're given data. Sometimes we could be given stats. But this one talks about the level of dissolved oxygen in a stream or in a river. And we're told that it's an important indicator of the water's ability to support aquatic life. The researcher measures this level at 15 randomly chosen locations, and we're given the results. So I think I left off pretty much this part in here, which would keep you from being able to do the problem. I went back, I added that. On Friday, I think there was 4 of us that were in the extra help Zoom session. I hope to see those numbers increase, especially if we had questions like there was with this. I was a little disappointed that there was only 4 of us in there. Hopefully that changes going forward. But you would definitely need the data as seen here, okay? And we have to carry out the problem, the hypotheses, conditions, all that stuff. So let's start with the hypotheses here. And no different than things that we've been doing. We have our HO, and we'll have our HA. Okay. With means, it should be mu. This one will always be an equal to. Okay. And it says the dissolved oxygen level below 5 milligrams. So if it equals 5, we're good. If it's greater than 5, we're good. And we're going to hypothesize, do we have convincing evidence that it's at risk? Meaning, does our data suggest that this level is less than 5, okay? The conditions, I'm not going to write them out. I'm going to show you my answer key in a second. But the conditions would be the random, we would have to check that, the 10%, and the normal large sample. Okay, but again, I'll get back to that one in just a second. What I want to show you now is how do we get this p-value? Well, we got to go to our calculator. And we would enter all those numbers just down one column here. Ignore these numbers that came up in columns B and C because that's after the test. I'll show you how to do the test again. But the first step would be to just open up a list and spreadsheet and put those 15 randomly selected locations or levels in here just like this. We also want to make sure we name our column. Okay, and I'll show you why. So once you enter the data and once you name the column, you can hit Control-I for insert, add data and statistics, click to add a variable, and you should see whatever the name is of the column that you just created should be right there. Here's a dot plot. Okay, here's something, guys, that we've been doing for a long time or throughout the years is graphing the data on the calculator, being able to graph it like this, and then ultimately changing the plot type to a box plot, which is something that is a little easier for us to work with. We're able to see strong skewness or outliers, neither of which is in this data here. Okay, so that's good because there's no outliers, because there's no strong skewness, we can continue. The condition has been met, all right? And once the condition's met, now I just got to find the p-value, and I'll find that by doing menu, statistics, stat tests, okay? Last section we dealt with proportions, 1 prop z-tests. Here, t-tests, all right? So that would be our final spot. We'd have to click on t-test. And like I said a few minutes ago, sometimes you could be given data, as we are here, other times stats, but we have data, all right? We hypothesize that it equals 5, or HO equals 5. The data can be found in column A. So if I want to leave it as column A, I can. If I wanted to put the specific title, also okay. what did we hypothesize as our HA? We are testing to see if aquatic life is at risk, meaning if it's less than 5. And my results are okay to go in column B. All right. Here's our p-value. For those of you that might not take this route, if you don't have an Inspire, you can still do the problem. You just need to get this test statistic and go from there. But those of us with the Inspire can just simply get that p-value and ultimately make our conclusion. So here's what I just posted in Classroom. Here's my hypotheses. Here's me checking my conditions. I use the calculator to get this number here. And then because this number is greater than this number, right, we fail to reject the HO. And when we fail to reject the HO, we're doing so because our evidence isn't suggesting enough that we have anything less than 5, meaning the aquatic life is not at risk, according to our evidence of this particular stream. All right, guys, so hopefully that helped. I think it should. Give this a look this morning, and I'll also post another practice problem. All right, guys, enjoy your day. Thank you, and please let me know if you have any questions.